Alright folks, welcome to Drunk Geology Part 2, this time sponsored by Keystone Light, since we somehow managed to sober up since last time. And one for the road. Alright. Excuse me. So now we're ready to start on cleavage. Oh boy. So, last time we differentiated between the east limb and the west limb of the synformal syncline. And now...
Scale finally, so.
Very nice.
What's good, Ben?
What's up?
How's your YouTube video?
You just
You're interrupting it. Go away.
That was the funniest start to that thing I could possibly imagine.
It's still rolling. Camera's still rolling, guys. Come on.
Let's leave it in.
I know. I don't know how to edit it out, so we're leaving it. Here's me. Alright, so now that we're starting, we cannot differentiate between the east limb and the west limb because we're looking for the axial plane this time. So, you're going to want to combine your data sets. To do that, you can highlight them individually like this and just hit like shift, click the top one, click all of them. I'm pretty sure you can copy, command copy on the Mac, command C. New data set, choose one, planes, and we're going to paste. Oh, no, and that does not work. That's fun. Paste, nope. So, we actually might not be able to... Okay, yeah, we're going to have to do this by hand. Fuck. Bear with me. So, I guess while I'm inputting all this data, we can talk about what we're going to do this time. So last time we looked at bedding. Now, bedding is different from cleavage in that bedding is a primary structure, S sub 0, not deformed by any tectonic activity. And being as such, it cannot really give us any information about the fold itself other than basic deformation information. That rhymes. That's funny. Such as like fold angle. So, you know, when you as you can see, I'm having trouble with inputting the data. So yeah, primary formations cannot give you. They can give you actually quite a bit of information about the fold itself, such as how much it folded. So, you know, as you saw, it's how much, to what degree that folded over. So in the synformal syncline we saw on Tanner Hill Road, you kind of, you know, you saw they're all dipping the same way. So kind of like this with the apex up here in the middle. That's that fold we saw where the cleavage was not parallel to bedding. That was the only point. But at every other point along Tanner Hill Road, we saw that cleavage was, in fact, parallel to bedding. This means that we can input the same strike and dip data we used for bedding into the cleavage data set. Now, you're going to want to uncheck everything you did before. I know, seems like a waste, but yeah, you still have all your data from before. Make sure not to delete it, but just uncheck it so you're not looking at it on the Stereonet and it's not confusing everything. This one you can use one color for, because what you're doing is you're taking every single strike and dip measurement you took, and we're going to basically average them all out. And what that does, much easier to understand than the bedding and the angle and how to interpret the angle between the folds, angle between the limbs. That gives you, how much it's folded. What we're doing here with cleavage is we're getting an axial plane, which is what divides the syncline in half. As Gene said in class, unless you're Kelly, skipping class, you have this fold, and at the hump, at the apex of the fold, there's going to be something that divides it in half in some way. Even if the fold's like this, you're going to have something that runs this way. There's some characteristic of the fold that you can basically bisect the angle and divide it in half. So that line that goes through it is not actually a line, it's a plane. And that is called the axial plane. And like I said, that will divide your fold in half. What we're doing now is we're inputting all our data. See, okay, I just put in the west limb data. And now I'm going to start putting in the east limb data, because we're going to average it all together. It can all be one color, one data set. We're going to average everything we took together. And once we average every single orientation we took, we'll get that average. We'll get that dividing in half thing. I can't do it with my hands. I'm drunk. Fuck. Yeah, we get that dividing in half plane right here. That orientation. So, that's going to be a lot of data inputting. Sorry, guys. But we're going to have to do it for the sake of science. And with the help of a few beers. Wow, I really sobered up since the last video. That's not good. Alright, I'm going to leave this data point out because in the field I made a note that it was deformed by something other than the limb. And I got an abnormally shallow dip. That's not good. And I don't want that messing up my data, so I'm going to leave it out. Hopefully Gene will be none the wiser. Everything's looking good so far. Everything's looking good. Striking fairly north overall. 1, 34, 354, 45. Everything's looking good. Due north, love it when that happens. 000. You always like to see that. Nice, nice and peaceful. Alright. 4 degrees off from north, 31 degree dip, 005 north, and 38. That should be all 7, 10. I feel like I have extra measurements in here. Did I repeat something? Hopefully not. Okay. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 measurements minus 1 because I took off a data point because it just looks bad. And yep, we got 17 data points. All right. There's all our bedding right there. Now, it's pretty simple from here. Just title this, no, not our bedding, sorry, cleavage. And title this cleavage. Actually, cleavage goddess, due to the pun Gene made in class. Not a pun, a joke. It was a joke. Cleavage goddess. Planes. Okay, we're going to go to calculations. Poles. Get all those nice little poles from that. You see those there? Yeah, looks nice. Alright, poles to cleavage goddess. That's your poles, and from there we're going to get our Fisher vector distribution. And scroll down, find that data. New data set, lines, because we're plotting a line. The mean pole, which is a line. Cheers. Alright, mean pole. This is going to be the mean pole of cleavage. Lovely. Plunge, as according to the Fisher mean vector, is 55 for me. Going to be different for you. Hopefully. Don't plagiarize data, kids. It's bad for you. 266 trend. Blazes it. See that yellow halo? Right smack dab in the middle of that. You like to see that, kids. You like to see it. So, you got the mean pole. Now what? Now, since you got the mean pole, you're going to want to plot your, well, you're going to want to distinguish it somehow. So, probably make it a different color. Everything's black up to this point. So, you know, might as well make it festive. We're going to want View, Inspector, Dataset, second tab over. Make it, what haven't we done? Purple. Purple's sorely underrated. It's like a nice, deep purple. Boom. Shakalaka. Make it bold, too. It makes it nice. Very nice. Okay. See your purple point there. That's your, right in there. It's your mean pole. From that mean pole, I'm going to extract some data. And by we, I mean me. Because you don't have to do this. Gene explicitly said this is not mandatory to do. But I'm feeling ambitious, so let's do it. We're going to plot a new data set. Small circles. We're going to plot that uncertainty in 3 dimensions. Plot it on 2 dimensions. Because this is a Stereonet. And we're going to do uncertainty. Now we're going to call it cleavage uncertainty. Trend, same as your mean pole. 266 for me, 55 plunge. Angle is going to, again, be your A95 value. That's your alpha 95. That is the area in which you are 95% certain the mean pole actually lies. And we can see that that is a very, very small area. So we are 95%, we're 95% certain that the mean pole lies within that circle there. That's pretty good. 95% is scientifically acceptable. Not again. No. Bad. Stay. Good. Okay. Cheers. So, that's a good spot for it. Now what do we do with that? You have this information, what are you going to do with it? Well, you're going to go to your mean pole of cleavage. You're going to go to calculations and planes from poles. And you're going to find, bingo, it's already in purple because we're awesome. Purple there. That purple line is everything. That is your axial plane. And as we said, that is the plane around which your fold hinges. That's going to be bisecting that fold. So that is the orientation of the axial plane. And you're going to extrapolate that data for Gene. I'm assuming you're going to put it in your caption. probably, I don't know if you're going to actually put the numbers in your caption. Let's see. So essentially, if you'll allow me to open, oh, not quite. So, no, sorry about that. Okay. So for content element 1, you're going to write Stereonet. You're gonna write a Stereonet caption for each of your Stereonets. And for Stereonet, the Stereonet of bedding, which we discussed earlier, you are going to include 3 things. You're going to include on the actual Stereonet the mean poles. You're gonna let's just demonstrate it for you here. For Stereonet of bedding, to recap, you're going to include the mean poles of the east limb. You're going to include the mean poles of the west limb. You're going to include the poles. You're going to include the poles of bedding on the east limb. You're going to include the poles of bedding on the west limb. You'll include the mean pole from the east limb and the mean pole from the west limb. You'll include the mean plane from the east limb and the mean plane from the west limb. So you have 3 things. 3 things there. Even though you'll have the poles, the mean pole, and the mean plane for both your east and west limbs on Stereonet 1. And when you go to describe that in your Stereonet caption, you'll say Stereonet of bedding in Synformal Syncline, Tanner Hill Road, New York. And then from there, you're going to launch into your explanation of what that means and include content elements 1, 2, and 3, plus your addendum. Do not forget the addendum. Equal area projection, lower hemisphere projection equal area, or whatever that is. You look it up in the 3030 handbook. If you don't have it, it's online on Husky CT. So for cleavage on your second Stereonet, you are going to project and plot all 4 things. Cleavage data, all those black lines. You can reduce the point if you want. If you want to reduce the weight of the lines, you can go to View, Inspector, Dataset, Weight. I guess you can do 0. No, you can do 0.5. No, I guess you got to do 1. All right. So they're going to be that thickness at minimum. You're going to plot your planes. Plot all the poles to those planes. Plot the mean pole, preferably a different color, please. Your axial plane, which is the mean plane of the pole, yeah, you're going to want to make that thicker. All right, so click on that. View, Inspector, Dataset, Weight. Like 3. All right, that's pretty thick. She thick. So that's your mean plane right there. That is your axial plane. Possibly include the data for that in your caption. Not quite sure, but possibly. I still have to figure that part out. I forgot to ask Gene about that. And okay, so there's that. So planes, poles, mean pole, and mean plane. There you go. Fifth element, if you want it, is cleavage uncertainty, which is that circle around your mean pole that indicates where your error. It's basically your error bars, but in 3 dimensions, mapped in 2 dimensions. It's that little circle. And you can include that if you like, but just definitely remember to include that in content element 1 or 2. I can't remember which one, but include it in one of your content elements in your caption when you're writing it. And remember to say that is your uncertainty. And that is the area, if you use your A95, that is the area within which you are 95% confident the mean pole appears. If you wanted to use your A99 and be a tryhard, then that is the area within which you are 99% confident your mean pole appears. which is pretty damn good. 95% is scientifically acceptable, but 99% is pretty damn good. But don't do that, because nobody does that. Like, seriously. Alright, guys, this is Drunk Geology. Down one for the boys. Pour one out. Chug. Oh. You know what I mean. See you guys later.